Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So in today's daily challenge on Leetcode, I am going to show you three methods starting from O of n square to O of n log n and also an O of n solution at last. And this will give a TLE because you can see the constant. If you have already tried the problem, these two approaches will be accepted by the Leetcode compiler. So yeah, if you like the video, then definitely subscribe to my channel. It gives me more motivation to make such good videos. So yeah, let's just start. Try to understand the problem statement at first. So lexicographically minimum string after removing stars, you are given a string. It may contains any number of star characters. Your task is to remove all the star characters. While there is a star character, what you should do, delete the leftmost star and the smallest non-star character to its left. So you need to process the string from left to right. Whenever you get a star, remove some smallest non-star character to the left, and if there are several such small characters, then you can delete any of them. So you need to return the lexicographically smallest resulting string after removing all the characters. Okay, so let's see this AABA. This, let's try to understand this example first, and then we will move on to the intuition. So we have the question AABA, and there is a star. There is only one star. Okay, and n is given to be 1e5. Okay, so now if you see, if you encounter a star here, you need to remove the smallest character. How many such smallest character are there? Three, right? This A, and this A. If you remove the first A, you get ABA. If you remove the second A, you get again ABA. If you remove the third A, you get AAB. Okay, so this, among all of these three, this is the one which comes first in the dictionary, and hence this is the lexicographically smallest. So if you try to see, whenever you get a star, you need to go to the left and see how many such small characters are there. Let's say the small character is B, and you know, if since it is a small character, you must remove the rightmost character. If you remove any other character, it will not be lexicographically smallest, because in the dictionary order, if you think, if you are removing, let's say, this first character small, okay, so the small character comes much after, and that will be more after in the dictionary. The And therefore, what you need to understand by looking at the problem at first is that you definitely need to remove the character which is on the immediate left of the star. Okay, so what you are doing, you are having a string, you are iterating from left to right. Whenever you will encounter a star, you just see which is the smallest character so far, and you delete the immediate left smallest character from the string. Okay, then again you encounter a star, then again you may be able to delete the smallest character, which may be here, which may be here, which may be anywhere. Okay, so you need to delete that. So this is the first intuition which should come to your mind. And an obvious brute force solution which will result in a TLE of order n square, which should come to your mind, is that I have a string. Whenever I get a star, what I will do, I will keep a map which will store all the frequency of the character traversed so far. So I have, let's say, the frequency of A to be 3, B to be 2, something like this. And whenever you get a star, you just go to check that you just keep storing in an answer string. So the answer string is so far this length. Okay, whenever you get something star, you just start traversing to the back of the answer string and remove the smallest character from the map. You will get which is my smallest character, if it has a count of more than 0 or not, right? You decrement the count every time and you can just get it, right? So what you are doing, so if let's say in the length n there are n by 4 such stars. I'm just giving an example, n by 4 such stars, and then there will be 3n by 4 such characters. Okay, so every time you will need to iterate. Whenever you get a star, for every star you will need to iterate of order n, so the time complexity will be order of n square. So this is a brute force solution. So let's say you have something like a b a star. So what I'm telling is that as you get you store in the answer variable AABA, as you keep iterating, you just store and get the map also. As you get this star, you just remove this A at first, and then your answer is now AAB. If there is a single star, return this as the answer. Then again, as you get this star, you can just remove this particular A. How you will get that particular A only? You can just start iterating from this N. So in every case, the length of answer will reduce by 1, but also you need to traverse the length of the whole answer, right? Which may be of the order N. It will be starting with 1, but it may be of the order N. Okay. This, after removal of this, what you will get is you will get AB. So if this is the star answer, so this will be the solution. This is a very brute force approach. This will result in TLE because ON is 1E5, right? And O of n square is nothing but 1E10. So for not giving a TLE, you must be doing in 1E7, close to 1E7. Even 1E8 will give a TLE. So that's why this even 1E7 is a quite a border case. So whatever, this will not work. So let's try to see how to develop further intuition for the problem. So you will be able to develop the next intuition only if you know something known as priority queue. Okay. So if you know about priority queue, how should this thing come into your mind? So as you are saying that I have got something like A, B, and then I am encountering a star, and then let's say I have more portion of my string. So I need the smallest character, right? Now there may be a C here. So let's say there may be a C here and then a star. The smallest character is A. So what you can do, you need the index to delete, right? To delete, you also need the index number. So what you want to do here essentially is you need to store every character and its index in a priority queue. Why will you use that? Because priority queue in general stores the maximum element at the first. So if you don't know, I'm just telling you, if you just do pq.push, let's say 3, and then you go for, let's say, 5, then you go for 6, then you go for 4, then the priority queue will have 3 5. 3 is the topmost element, then it will have 5 3. 5 is the topmost element. In every operation, it takes log of the order of number of elements in the priority queue. So overall, if you are entering n elements, it will be n log n. So it will be 6 5 3. So if you enter 4 next, it will be 6 5 4. So the top element in the respective case will be these 6 only. This is the general priority queue, which is implemented as a max heap. So priority queue, there is also a syntax of a priority queue where you can implement a min heap. Here we need the minimum character, right? So that's why we need the minimum. That's why we need the min heap here, because we need the minimum character. So what we can do, you see that when we are going to replace, we need which minimum character, which will be defined by the index. So we can store a priority queue of type character comma index. Okay, pair of character comma index. You can store this type of priority queue. By default, you will get the character which is at the front, which is minimum. If you are using a min heap, you will get the minimum character at the top element. You will get the character which is the minimum, and if the two characters which are minimum is the same, you will get the minimum index. Okay, you will get the minimum index, mind it. But here you need the maximum index because you are traversing from the left, right? So why I am telling maximum index? Because the index of A here is 1 0 1 and 3, right? So you need to get 3 at first and not 2. So what will priority queue store here? It will store A comma 0, A comma 1, A comma 3, and this will be the topmost element because this is the minimum element, right? So what you can store something like character and minus of integer. It is still an integer. It is not, I'm not changing the type, but while pushing, you can store minus of index. So what if you store the minus of index now? This will get minus, this will get minus, this will get minus. Now among all these, which is the least element? A is first of all the least element, so it gets stored at first. And among all this, -3 is the least, right? then again -1 is the least, again 0 is the least. So now you will get a priority queue whose top element is a comma -3. Okay, and when you want to use this index again, suppose you want to change the character, right? You will definitely be needing to change the character. So you can again do a minus and extract the indices. So in this way, whenever you get an element which is not star, you can push in the priority queue. Whenever you get an element which is star, you can pop from the priority queue. You will get all the elements and their indices which are remaining. Okay, and after that, what you can do, let's say you have this string, some string you have, let's say D, E, G, something like, and you saw that there were some stars, in the middle also. But after all those manipulations and all, the priority queue has, let's say, some elements, and those elements only need to be there. Okay, so you can do something like, you can initialize a string which is of star, right? Which is completely star. Okay, of this n length only. Now you go to this element. Now you go to the 3 index. You go to the 3rd index and initialize an a here. You go to the 1st index and initialize an a here. Whatever be the remaining elements of the priority queue, that because for every star I am popping an element, right? So whatever will be the remaining elements in the priority queue, that will be going to my answer. Okay. So how will this work? We will also understand while coding. So let's just start to code, and then we will also understand things on the way. Okay. Now you need to initialize the priority queue. So let me tell you how you initialize the priority queue. First of all, priority queue is initialized by this syntax, priority underscore queue, which is of int. If you are initializing it something like integer, as I told you, 5 in the example of 5, 3, 4, 6, stuff like that, you will do int. This will give a max heap. Okay, but for min heap, the syntax you can check from GFG. You can just search in the web and check for GFG. It is something like int vector of int, okay, and greater of int. So I'm just adjusting the space here. Yeah, so and greater of int. This is the thing which priority queue is initialized by. But here, instead of integer, we are having a pair. So we need to replace this pair, integer by pair. So let's see how to initialize this priority queue. If you don't know this initializer, just quickly go and check out in the GFG, initializing a min heap which stores a pair, character comma integer. Okay, so if you want to initialize a which stores only integer, okay, so what you will do in that case, priority queue min heap, if you do something like this, if you just initialize it, like, it will be a max heap. It will store the maximum element at the top. Okay, but if you want to store something like, it will store the minimum element, then the syntax goes something like this, greater of integer. Okay, this is when we are storing some integer, but here we are storing a pair of character comma integer. Okay, so all the integers I will replace by pair of character comma integers. I will go to all the integers and I will replace it by pair of character comma integer. Okay, so yeah, we have that. This is how you need to initialize a priority queue. Okay, so what you do is very simple. From now on, you just iterate through the string. If the string of I is not this character, means you have a char, then what you need to do, q.push this element pair, which is nothing but s of I, and as I told you, you store minus of the index. You need the index number, and you need the greater index at the first, because from the left, because that's the greedy method, as I explained you already. So that's what you need to do. And whenever you get this, you just do a pop. Whenever you get a star, this is not a star. So whenever you get a star, you just do a pop. Okay. So now what you can do? You can initialize a vector of character. vector of character. You can initialize a string also. I'm just doing this. Length n, and you can initialize every element by a star. Okay. Now every character is star here, but we need the characters which are remaining at the priority queue, right? So while PQ is not empty, what I will do? I will go to the character. I will extract the characters tree. How this will be? It will be pq.top.first. I extract the first element of the priority queue, top element, and among the top element, I am storing this is the character is the first, and this integer is the second. Okay. So this integer index also I get it in a similar manner, pq.top.second. Okay. And what I do now is very simple. I go to the string, I modify the index, replace it by the character C. Because those are the characters which need to be present at that index, right? And you do a pq.pop. That's important to do. But this is not our final answer, right? What will be our final answer? If you try to see what will be our final answer, our final answer will be all the non-star characters here. What we will do with stars, okay, right? We don't need to do anything with those stars. So this will be a non-star character. So it's quite simple. You just iterate through all elements of this star and just do answer plus equal to str of I. So not every time. If this str of I is not a star, then only you do answer plus equal to str. Okay, and you just return answer. Let's try to run it and see if it works or if it will fail in some cases. It's giving a runtime error. Let's try to see what's the problem here. We have initialized this and we have this pair of character comma integer. Okay. It's quite. I have stored this negative, right? So, but why did I do negative? Because I need the maximum value to be at the top. That's why the negative value of the maximum is the minimum, and it will be storing at the top, right? But if you see, this index is a negative, and I am trying to access a negative index here. So I need to do this negative also to make it again positive, right? So yeah, we have the accepted thing. Let's try to submit it now. If it works. Okay, so yeah, it works. Runtime complexity is not so good because it's still optimizable. Let's go ahead with the ON solution. It is not that much intuitive. It's there in the editorial. So I will just explain you. So what you need to do now, what you can do is first you realize that at every character is either from A to Z. It cannot be more than that. Okay, and you get a star. So, and I need to track the index of every character because for every star I need to delete the character from the rightmost element, right? So what you can do is quite simple. You can maintain the status of all the characters. What do I mean by status? Let's say these are the headings, these are the columns of a table, and you store the indexes of every character. Let's say this is the character A. When you will receive at first, let's say that index is 2, you store it. Let's say B you receive at index 0. Then again another A you received at index 4. Similarly, you keep on storing in this manner. So you can, and whenever you get a star, you can just pop this element. So you can see that every element, everything need to be a stack because you are popping this element and entering from here also. So what you can initialize is a vector of stacks. Which will store the indexes of all the characters. Okay, so you need to initialize this. And whenever you get something which is not star, you go and store the index, and something which is star, you iterate through all these characters. Whenever first you get something which is not empty, you just go to the string and again modify that and just remove that value. How to remove that value? Let's say this star removes this value of A. Let's say it has a A here. in the case of the example, you have a something like this. This star will remove this a, and let's say we have another star, and this star will remove this a, not this a, right? So what we can do is that here a will be like 0 1 3. So when we get a star, b will be like 2. Okay, so when we get a star, we will see that we want to replace 3. So what we can do, we can replace this string of 3 with another star. Okay, so what will be now the result? Now a b b star star star. Then we are, when in this star iterator is in this star, we will check, we will pop this out and from the stack, and we will check s of I, we will set s of I to be star again. Okay, so this I will also be star. Now the string contains of something like this. So at the end, you just iterate through this string. Whichever elements are not star, you just keep answer plus equal to that si. Answer plus equal to si if it is not star. So at the end, you will get an AB here. Okay. So if there was a single star, you can also understand that you would have got an AAB here. So that's all. That's all for the ON solution. If you see, this is of the order of 26, right? And the complexity is now 26, and which is nothing but ON. Okay. So yeah, you can just go with it. I'm just removing this part. Initializing stack. So first of all, initialize vector of stack. Initialize vector of stack. So how will you do that? You have something, these stacks of count. I will call it count, and it stores every element in the form of some table, right? So what we can do is that you can do is that you go through with all the elements. Okay, if this s of I, if this s of I is not the star, what will you do? You can do simple count of this s of I minus a. You need to go to the index of that count first. You need to go to the index and you need to push the value of the current index. Okay, go to the index of the stacks and put value of the current index of that character. Okay, if it is not a star, what if it is a star? You need to remove the minimum element. So you can just start a loop from 1 to 26. Okay, if this count of this character, you are checking all the characters from A to Z, and the first you need the minimum character, right? So the minimum character, when you get, if the count is not empty, dot empty, if it is not empty, what you can do? Can you tell me? If it is not empty, what will you do? I will do count of j dot top. I extracted the index. I extracted the index of the current element, and as I told you, I will go to that index. I will extract this index. I will go to that index and store a star here. Okay, so I will go to that index. Okay, and I will store a star here. Definitely, we need to pop the last element also. We won't be using this. And once you have got some element which is non-empty, you do not need further, right? Because if for a one star, you just need to iterate it for once, right? If you get the minimum character, all the other characters will be the maximum one. So you need to delete the minimum character only. So that's how you will get that. And now it's simple. You can just make a string answer, and you just iterate through all the elements of this s and do this exact same thing. If s of I is not equal to this star, all you do is answer plus equal to s of I. Return answer. Yeah, if it's not a star, just do that. Let's say it's try to, if it works, or have I committed some errors? So yeah, it does show the accepted thing. Let's try to submit it and check. Yeah, you see, we got a increased runtime complexity, but our memory got decreased from the last one. So you cannot achieve everything, right? So you are using 26 stacks here. So definitely you are using more memory than just using a priority queue. So yeah, that's all. That's all for this video. I hope you like the video, all the three approaches. If you don't understand any part, definitely you can comment the timestamp. And if you have reached the end of this video, I will just do a small request to you. You just just so that I get to know, you can write in the comments you can just write in the comments, yo bro. So I just understand that how many such aspirants are there for top software companies who are actually preparing seriously and following my channel. It just gives me more motivation to make such videos and nothing else. So yeah, that's all for this problem. This was a medium kind of problem, but I hope your day is going to be really easy. Thank you so much.